Welcome to the DIY Honda Garage channel. The DTC P2073 indicates that the manifold absolute pressure MAP sensor is reporting a signal that is higher than the expected values within the Honda Civic models from 2022 onwards. The MAP sensor plays a crucial role in measuring the pressure within the intake manifold, which is vital for determining the engine's air-fuel mixture. When this sensor indicates an anomalously high pressure reading, it disrupts the engine's performance. This situation triggers the Powertrain Control Module, PCM, to store the Diagnostic Trouble Code, DTC, and bring attention to the issue. The PCM compares the MAP sensor output with the barometric pressure, BRO, sensor output and the turbocharger boost sensor output. If there's a significant deviation between these measurements during certain driving conditions, it indicates a fault. This code might affect the vehicle's fuel efficiency, exhaust emissions, and overall engine operation, necessitating thorough troubleshooting based on the outlined procedures. The MAP sensor is designed to gauge the pressure within the engine's intake manifold, an essential task that assists in calculating the appropriate air-fuel mixture necessary for optimal engine combustion. It is usually located near the intake manifold, and both the baro sensor and the turbocharger boost sensor serve as reference points for its readings. If the readings deviate significantly from what the PCM, or Powertrain Control Module, anticipates, the PCM will recognize this discrepancy and store DTC P2073. Such deviations can arise from various factors, including leaks in the intake system or malfunctions within the MAP sensor itself. Identifying these issues is crucial because they can lead to diminished engine performance, increased emissions, and other complications that significantly affect the vehicle's functionality. Thus, proper inspection and diagnostics of the MAP sensor and related components are necessary. Several factors can contribute to the activation of DTC P2073. A faulty MAP sensor may fail to provide accurate readings, resulting in skewed data that impacts engine performance. Another possibility is a leak in the intake system, which can cause an excess of air to enter the combustion chamber and lead to erroneous pressure readings. The EVAP system refers to the system that prevents fuel vapors from escaping into the atmosphere. And issues within this system can also affect the MAP sensor's readings. Similarly, defects in the PCV system, which helps recycle engine gases, can disrupt the pressure balance needed for proper operation. Furthermore, leaks from the turbocharger system could also result in inflated pressure readings, triggering DTC P2073. A comprehensive understanding of these potential failures is essential when diagnosing the root cause of the problem. When DTC P2073 occurs, various symptoms can manifest, impacting the vehicle's overall operation. One of the primary symptoms is a reduction in engine power. The driver may notice a lack of responsiveness when accelerating, as the engine struggles to adjust to the incorrect air-fuel ratio. Idle conditions may become unstable, leading to rough idling or stalling. Increased fuel consumption is another notable symptom, as the engine attempts to compensate for the unmeasured air entering the intake manifold, causing inefficient combustion. The check engine light, or CEL, will typically illuminate when this DTC is present, alerting the driver to a potential issue. Moreover, the vehicle may exhibit delayed or poor acceleration responses due to these underlying issues, making it crucial to address the DTC without delay. The first step in troubleshooting DTC P2073 involves starting the engine to initiate diagnostics. Once running, it's essential to hold the engine speed at 3,000 RPM without any load. This means that the continuously variable transmission, CVT, should be in park or neutral, or if the vehicle has a manual transmission, MT, it should also be in neutral. Maintaining this RPM is necessary until the radiator fan engages, indicating that the engine has reached a certain operational temperature. Afterward, it is vital to let the engine idle for a minimum of 5 seconds to ensure proper pressure settles in the intake manifold. This procedure creates a baseline from which further diagnostics can be conducted, allowing for more accurate readings relevant to DTC P2073. After starting the engine and allowing it to idle, the next phase of troubleshooting requires a test drive under specific conditions. As part of this step, it is essential to monitor the engine speed, ensuring it stays above 1,700 RPM to create sufficient operational stress for the engine's systems. If the vehicle is equipped with a CVT, it must be set to drive, while a manual transmission should sit in either 4th or 5th gear to replicate the necessary load conditions. The vehicle should be driven for at least 6 seconds, allowing for the various sensors, including the MAP sensor, to gather data during dynamic conditions. This step is critical to see if the DTC P2073 reactivates during real-time operation, providing deeper insights into its causes. Following the test drive, the next step is to monitor the Honda Diagnostics System, HDS, for changes in the onboard diagnostics OBD status. This tool provides crucial real-time feedback regarding the vehicle's performance and sensor outputs. It is essential to check for the reappearance of DTC P2073 during this monitoring phase. If the code does reappear, it indicates that the problem persists within the MAP sensor system or its related components. Documenting the results of this observation is necessary for future reference and for conducting further diagnostics. Depending on the outcome of the monitoring, you would proceed with additional diagnostics or repairs focusing on identified issues. This systematic approach helps to narrow down the cause of the DTC to implement the right solutions effectively. The fourth step in the troubleshooting process requires a visual inspection of the intake system to identify potential vacuum leaks. This task involves meticulously examining areas, such as the intake air duct, intake manifold, and the positive crankcase ventilation (PCV) valve and its associated hoses. The EVAP system components, like the purge valve, also need to be inspected since they contribute to the overall integrity of the intake system. A fault found within any of these components can result in abnormal pressure readings that trigger DTC P2073. It's also important to check the throttle body and all sections leading to the turbocharger joint, as leaks there can significantly impact sensor performance. Confirming that there are no visible leaks or damaged components is vital in ensuring proper function and preventing further issues. In the fifth step, you must ensure that the MAP sensor is functioning correctly through functional inspection. You do this by turning the vehicle's ignition to the on position without starting the engine. At this point, the Honda Diagnostic System, HDS, should be used to confirm the readings from both the MAP sensor and the turbocharger TC boost pressure. It is essential that the MAP sensor high-resolution value and the TC boost pressure differ by less than 26.7 kilopascal, which corresponds to about 7.9 inches of mercury or 200 millimeters per mg. These specifications serve as thresholds for normal operation. Any deviations can signal a malfunctioning MAP sensor. If the sensor values exceed this tolerance level, a replacement or further inspection may be necessary to address the issue effectively. For the final step in troubleshooting, once you've confirmed normal conditions from the previous steps, you will perform a detailed check of the MAP sensor's functionality. Begin by recording the MAP sensor's high-resolution value while the vehicle is still in the on position. Then, start the engine and allow it to settle into an idle state. At this point, it's crucial to monitor the HDS display for any changes in the map sensor value. According to normal operation, you should see a change of more than 0.67 kilopascal, approximately 0.2 inches of mercury, or 5 millimeters Hg, indicating that the map sensor is actively responding to engine changes. If the sensor output does not meet this requirement, the map sensor may be faulty and require replacement. This thorough evaluation ensures that all potential failures have been analyzed systematically, leading to effective repairs. After completing the troubleshooting steps and performing any necessary repairs, it's essential to conduct a final verification of the repair work done regarding DTC P2073. Start by clearing the DTC from the onboard computer system using the HDS tool. Next, take the vehicle for a test drive under conditions similar to those when the DTC was originally triggered. Pay close attention to any signs of abnormal performance during this drive. Ensure that the DTC does not reappear during this period, as that would indicate that the issue may still persist despite repairs. Finally, make a thorough evaluation of the engine's performance post-repair. Key indicators to monitor are engine power, acceleration, and idle stability. This step is critical in confirming the effectiveness of the repair process and ensuring the vehicle is operating in optimal condition. To minimize the chances of encountering DTC P2073 in the future, implementing a preventive maintenance routine is highly advisable. Regular inspections of the intake system can spot potential issues before they escalate, such as small leaks or component wear. Checking vacuum lines is particularly important, as a single crack can lead to significant performance issues. The map sensor itself should be serviced periodically, ensuring its accuracy and functionality over time. Additionally, maintaining the efficiency of the EVAP and PCV systems can also help uphold proper pressures within the intake manifold, thus reducing the likelihood of DTC triggers. By being proactive in your vehicle's maintenance, you can prolong its lifespan and enhance its performance. In summary, DTC P2073 signifies a malfunction related to the MAP sensor that can significantly impair engine performance and efficiency. This condition can lead to reduced power, unstable idle, and increased fuel consumption. Therefore, thorough and systematic troubleshooting is essential to pinpoint the root causes effectively and initiate adequate repairs. Regular maintenance practices can help mitigate future occurrences of this DTC, as they promote the continued health of the various systems involved, such as the intake, EVAP, and PCV systems. Monitoring symptoms that arise can also allow for early detection of potential issues, ensuring the vehicle remains in optimal working condition. Ultimately, adhering to these guidelines will lead to a more reliable Honda Civic and a safer, smoother driving experience. Please like and subscribe to the channel. See you next time!